do have different strengths. This might or should at least be obvious to you if you know the difference between battery acid and vinegar. They're both acids, but one of them's a little bit stronger than the other. I'm going to teach you how to differentiate between the two. So in chemistry, strong acids are only these 6. These are the only ones that we can call strong. They're hydrochloric, hydrobromic, hydroiodic, sulfuric, nitric, and perchloric. The names of these are given in a chart in the class notes that I've provided on Canvas. So you can go through and write those down as if you need to, or you can pause me and Google it or whatever you need to do to get those down. You do need to know these. You need to know all 6 of them. You need to know what their formulas are and what they're called. And the reason that they're called strong acids is because they do something called dissociate, and they dissociate completely. They do not stick together in a solution. So it's like if this is an atom right here, they're both together. When I dissolve this in water, it will separate. And it will, all of the particles that are in water will separate, every single one. That's what defines a strong acid, is the complete dissociation. And we'll talk more about that here in just a second. Weak acids include every other acid. If it's not on that list of 6, it's not a strong acid as we define it in chemistry. That's everything from hydrofluoric acid, which many people think is the strongest acid. And it is pretty strong, but it's not one of the strong acids, all the way down to vinegar. Everything is a weak acid except for those 6. Okay, again, with dissociation here. So if you look at this chemical formula right here, hydrochloric dissolves into H plus and Cl minus in an aqueous solution. That's what that AQ means. Basically, if you have a HCl atom, you put it in water, all of it is going to dissolve. And that's what this means right here. So at the start of a reaction, we have 100% HCl. But at the end of that stuff dissolving, we have 0% HCl, and 100% of that has turned into H plus and Cl minus. But a weak acid is not going to do that. This, for example, up here, C3COOH is going to dissolve into H plus CH3COO minus. But not all of it will. Some of it's going to stay together. And so if we look at these percentages down here at the bottom, once my toolbar disappears, if it disappears, there we go. You can see that 95% of the acid that we've put into the liquid has stayed together. Therefore, it's a weak acid. It hasn't completely dissociated. So this is the definition of dissociation. It just means breaking apart into ions. That one is important for you guys to know. Again, strong acids and bases dissociate 100% of the time. Weak acids and bases will dissociate less than 100% of the time. That's the only difference between them. Now let's talk about bases. Strong bases are any alkali and alkali earth metal hydroxides, except for beryllium and magnesium. Those two are not going to completely dissociate in water, but every other alkali and alkali earth metal, except for like the big radioactive ones, those are strong bases. The most common ones that I use are typically sodium hydroxide and potassium hydroxide. These are the ones that you really should focus on. We have lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide, and strontium hydroxide. Those are the ones that I mostly have in my stockroom that are most often used. Weak bases include every single other base. Ammonia, bleach, anything that's not those 6 is, or the ones on the periodic table, those are not strong. They won't dissociate completely in water. Here's another example for you here. A strong acid is going to break down completely, but we see at equilibrium over here for this weak acid, there's still some concentration of HF. If you look at the differences between these two pictures, you can kind of see it. I should also have a YouTube video of dissociation happening at some point, like a little molecule simulation video, but that might take me a while to find. That's it for acid-base strength. You're now able to go take the quiz on Canvas.